So when we use perpendicular segments in proofs, there's a couple things we do. We could use the right angle as a congruent angle, or we can use the right angle to say that the triangle must be a right triangle, in which case we would use HL, which is hypotenuse leg. So let's say that I gave you that AD is perpendicular to BC. So I know these angles in here, 1 and 2, must be right angles. So in a proof, your next statement is always going to be that they're right angles, and that's because perpendicular lines create right angles. Okay, but your next step depends on whether you want your proof to be HL or whether you want it to be side, angle, or angle, angle, side. Okay, so let's say, for example, I want it to be HL, so I'll just do another color here. Suppose we mark the AD is congruent to itself, so that would be a leg, and then I also know that AB is congruent to AC. So when you look at this diagram, you have side, side, angle, which we know we're never going to use. That's not a way that we prove triangles are congruent. However, because I know these are right angles, these are right triangles. And I have a leg and a hypotenuse labeled. So this would then be HL. So like we said, I'd still start out by saying that these angles are right angles. Angles 1 and 2 are ADB and ADC. But my next step would be that triangles ABD and triangles ACD are right triangles, and that's because a triangle that contains a right angle is a right triangle. Okay? And then you'd have them proved by HL. So like your next statement would be triangle ABD is congruent to triangle ACD, and that's by HL. But, okay, now here's where people get confused. What if I say that my other givens here, so let me just erase this for a second. What if I change up my givens and I say that this side is still congruent, but maybe now I have these two sides congruent? Now I have two legs here, so that's nothing. But I do now have side, angle, side. So remember, we still start here. That's always going to happen. But our next statement is now that they're congruent. So in my diagram here, these are right angles, and then right angles, all right angles are congruent. And then your next statement would be that triangle ADB is congruent to triangle ADC by side, angle, side, in that particular example that I came up with. Again, this is assuming that I already talked in my proof about those congruent sides, but just kind of talking about that end piece there. Just because you have a right triangle does not mean you're always going to use HL. Sometimes it's going to be side, angle, side, or angle, angle, side, and then other times it's HL. Okay, so if you're using HL, you need to talk about the right triangle. If you're talking about these three, then you need to talk about why the triangles have a congruent angle, why the right angles are congruent. So let's try this out down below. So I've got ABD perpendicular to AC. AB is congruent to BC. And I want to prove that these two triangles are congruent. So this is just like what I was writing up above. Let's call these angles 1 and 2. So if I'm going to prove these triangles congruent, I see there's a shared side here. So this would be not side, side, angle, but it would be hypotenuse leg. Okay, but I'm going to have to talk about why these are right triangles in order to even say hypotenuse leg. So I'm going to write out my givens. Okay, so let's talk about those angles. Just wanted to rearrange this more space down here. Okay, so let's say that angle 1 and angle 2 are right angles. Okay, because remember they told me about perpendicularity. And that's because perpendicular lines create right angles. Now my next step is not that they're congruent, because I'm not using that they're congruent in my proof. My next step is saying that the triangles are right triangles. So ABD, triangle ABD, and triangle CBD are right triangles. And that's because a triangle that contains a right angle is a right triangle. Okay, so now that I have that, keep in mind that AB and BC, those were the hypotenuses. I don't know if that's a plural word. It's the hypotenuse. I don't know how to say that. The hypotenuse in each triangle is marked. And then 1 and 2, I got this. I have the right triangles. I also have to talk about the leg still though, right? So BD is congruent to itself. So there's the leg I was looking for, and that's because of reflexive. It's that shared side. Okay, so now I've talked about everything I have to talk about. I've got the hypotenuse, I've got the leg, and I've got the fact that it's a right triangle, which is important. So now I can say that triangle ABD is congruent to triangle CBD, and that's by hypotenuse leg.